Hello. In this week's content, you're going to review some of the drawing systems that you covered last semester in Architecture 2A, and then we'll go a little bit deeper into one of them. Let's start out with that review, and we'll cover orthographic, paraline, and perspective drawings. What are drawing systems in general? Well, they are a way to think about and represent the three-dimensional object that we see on a two-dimensional page. And the different drawing systems have different benefits, pros and cons, and different ways to observe and look at the objects. So here you see an example of a three-dimensional object displayed in three different drawing systems. Here's a second example of one object displayed in multiple different drawing systems. You can categorize these drawing systems into orthographic, paraline, and perspective drawing systems. We're going to start with the orthographic projections. Remember that these orthographic drawings are going to describe a three-dimensional subject through a series, not just one, but a series of related two-dimensional views. This drawing system is more abstract than the other three-dimensional systems, which are more pictorial. Starting with the basics of orthographic projection, imagine a sheet of glass parallel to the front surface of a three-dimensional object, and your view of that object will be directly 90 degrees projected from the object. Now, instead of one glass pane, we can imagine our object surrounded by a glass box and visualize the orthographic view from each side of the box. Each one of those sides shows only two of our three dimensions, and therefore viewing any one side of the box or any one drawing, the entire three-dimensional object can't be fully understood. That leads us to multi-view drawings where individual views are arranged. Usually we show three views, top, front, and side, but if you need to, you can add additional views. Take a look here at the chair drawing. This should bring back some good memories. And remember how your top, front, and right side views are aligned. Especially, don't forget that important diagonal to relate your top and your side view. Orthographic drawings are very commonly used in architecture. Plans, elevations, and sections are all orthographic drawings. Let's move on to our next category. It's paraline drawings. These type of drawing systems will convey the three-dimensional nature of your form or your object in a single view, unlike the orthographic projections. They're popular because they are scalable. You can understand the scale or the size of your object, and they're easy to understand. So, some characteristics of paraline drawings in general, and this is going to hold true for both isometric and oblique. All right. Number one, parallel lines remain parallel. They don't converge. Perspectives, they converge. Paraline drawings, no. Number two, measurements along the axial lines, okay, are scalable. You can pull out your scale and measure them. This is unlike the perspective drawings. And number three, paraline drawings are always going to be either aerial or worm's eye view. One of the most common paraline drawing systems is the isometric projection. It is a subset of axonometric projection. And in isometric, the three principal axes, the x, y, and z axes, are 120 degrees apart. So if you see them on a drawing page, your horizontal axis is going to be 30 degrees from the horizontal. In isometric projection, all lines parallel to the major axes are true scalable length, and we draw all three axes to the same scale, as opposed to oblique. Oblique projection is another type of paraline projection. And with this one, we orient one principal face of your form or your object parallel to the picture plane. Remember that sheet of glass that the observer is looking at, right? And we can draw that one plane, that one face to exact scale, and it will accurately represent its shape and proportion. There are two major ways that architects use oblique drawings, and those are called plan obliques and elevation obliques. In the plan obliques, we orient the horizontal plane directly at the picture plane, and therefore everything that is in the plan view is true to scale, right? The advantage of this, and it's a big one, is that you can use the floor plan as a base drawing. The elevation oblique, slightly different. We orient the vertical plane, one of the vertical planes, one of the vertical faces of the building with the picture plane. Right? And the advantage of this one is that you can use an orthographic elevation of the building to start your base drawing. There's a couple of choices you can make in the oblique projection system when you're setting up your drawing. And the first one is which surface you want to choose parallel to the projection plane. Is it a plan oblique? Is it an elevation oblique? Right. The next one is the angle. Right. So in isometric, you're always going to choose that 30-degree angle. Oblique projection, you can choose whichever angle you like. All right. But it's really common to choose 30 degrees or 45 degrees. And finally, there's the idea of foreshortening. You can choose to depict the receding lines in elevation oblique, that's in this direction, in plan oblique, it's in this direction, that depict the object's depth to a smaller scale. And this typically gives a more realistic view of the object. Let's move on in our whirlwind tour of drawing systems here to the third category, which is perspective drawings. Perspective drawings represent an experiential view, and they depict an optical reality. There is always one point of view, the eye's point of view or the camera's point of view, and they are also challenging to construct. Let's take another look at the difference between experiential views and objective views. Perspective drawings are experiential views. They assume that there is an observer, which is located at a specific point in space and looking in a particular direction. Objective views, including the orthographic multi-view drawings and the paraline drawings, all right, they don't make any reference to a specific point of view or a specific observer. In the one-point perspective drawing system, one elevation, one side of your form or object will be directly facing the observer, and all of your perspective lines will converge upon a single vanishing point located on the horizon line. In a two-point perspective view, you're more likely to see your form or object turned slightly, so you are looking at an edge of that object, and your perspective lines will vanish to two different points on the horizon line. Okay, you just did a quick review of many of the different types of drawing systems. Thanks, everyone.